Hello everyone, welcome to the session on AWS Lambda. So as a part of our serverless journey, this is a compute layer which helps us in defining the business logic. So let's begin with the today's topic. So before we move into the actual what Lambda is, let's understand how AWS came up with this. So initially there were a few servers. As we know that the traditional approach, we have to provision some servers in order to uh, take into account some of the operations that are required for our application. So all those operations need to be in such a way and in such a order that it is compatible and our servers can handle those operations. So it was very difficult for the people who were not sure how much will be the operation or what will be the amount of time, the processing time that will be required by the server. So they came up with this model wherein they provided us with the service that allows us to run our code independently, like without thinking much from the provisioning the servers or having some background hardware setup for you. So that's the important aspect, wherein we need to work with serverless, because we actually not sure what will be the number of requests or what is the computation part of things that will work when we use the servers. So AWS Lambda first introduced in November 2014. So AWS came up with this service in November just to meet the requirements of computation or to work with a system which will automatically scale depending upon the number of operations that happen on your side. Okay, so let's move on. So let's understand what is AWS Lambda. So it's a, as I mentioned earlier, it's a serverless. It's a compute service that runs your code virtually on any type of application, or you don't have to manage or provision any of the servers. It also makes your code highly available. That means if there is a too much traffic on your site and you're not able to handle that traffic with your traditional servers, then this Lambda actually helps you in handling and scaling your application such that you don't have to actually worry about keeping some more data centers or having some backup system to divert some traffic to those idle systems. Everything is taken care for you and you just need to work with your code and the business logic. So they have the capacity provisioning, automatic scaling, plus if you want to monitor the code and if you want to debug the things and find out what are the issues that happen on your application, then it is by default already set up for you and you just need to enable the monitoring in order to find out more about the issues on your platform. Now let's understand how it works. So this is a basic example that I have put here. There can be different approaches or different AWS services which you can use along with Lambda. So in this case, I am having my application stored in the S3, which will act as an entry point. That means if I'm having a website and if I want my users to access that website, then this website is normally the files of these websites are now kept in S3. Okay, so once user clicks on any of the components that are there on our website, then that information we are sending. Like if you want to get the weather information, then if the user is particularly in a specific region and he just clicks and allows to access for our app to access the location, then that location will be sent to a API gateway in a request body. Okay, then we have our Lambda connected to Amazon API gateway. Now Amazon API gateway, those who have missed, we had it covered in our last session. So it's like basically a entry point which handles the request from the users. So it sends the data to the Lambda, and then Lambda uses this information which is sent in the request body, and it makes a request to DynamoDB to pull in the information related to the weather, and it then again sends it back to the API. Okay, so Lambda basically acts here as a connection between DynamoDB and API gateway. So those who are not aware of DynamoDB, it is just, you can consider it as a database where we store the records. Okay, so in Lambda we are just making a call to DynamoDB, pulling the records from the database and sending it back to the API gateway, okay, to the end user. So this is a basic example wherein you see how the Lambda is used. Okay, we will actually check the code and what underlying things that are there under Lambda. Okay, now let's understand what are the different components that are there in Lambda. So for that, I'll just take you guys to the a function, a Lambda function. So what you see here is the sample function that is being used to pull the records from DynamoDB. Okay, so if you see here in this function overview, I have different components. So first one is trigger, then there is a layer, then there is a destination. So this actually comprises of your function overview. So in trigger part, as we had seen in the previous case wherein we had our API gateway connected. So in this example, in this function, I have API gateway as my trigger. So basically, if I want to execute my Lambda function, I need something that will trigger the Lambda function. So in this case, API gateway acts as that trigger point. Okay, and at the destination, I don't have anything right now, but destination you can consider as another AWS service which you can integrate. Like if you want to broadcast a message to different users or the customers, then you can use SNS or SQS, all those type of services to be set in a destination. Okay, what this layers does is, if you want to integrate a third party library, or if there are some dependencies in your code wherein you need to make if you want to make use of libraries that are open source, or for this part of the code wherein you need to do some JSON formatting or any of the default libraries which are any of the libraries which are not defined in default libraries, then those third-party libraries you can add using these layers. Okay, so this is a part of first part of the component that is defined in function overview. Next one is the actions. So the actions is the button what you see here. So basically, if you want to release multiple versions of your Lambda, like how we have GitHub, wherein we have the version control system, we have our method to trace what are the different aspects in terms of code. Okay, so if you guys are not aware of version control system, then you can understand it as something wherein at different point of time it might so happen that you want to come up with new releases, or you need to come up with new improvements. But what if your new improvements is not able to take up the load, or the overall it is not able to perform better as per your expectations? Then you want to revert your current version to the older version that is working fine. Then for that reason, it is important that you have different versions with you. Like you need, so basically this new version, publish a new version helps you in coming up with newer versions. Like if you are using a smartphone and if you are using a Android system, operating system, and for Android, how you have different releases. So this Lambda function acts in the same way. Okay. Next is aliases. So alias is actually helping you to make a connection and use different versions that are released. Okay, so if you want to serve a traffic wherein some users need to use older version and some users need to use newer version, so you can use alias in conjunction with this new published version, and you can serve a different set of users using this alias. Similarly, you can export your function, that is your code. You can delete this function, and these are the other options that are available for you. Then there is another option to throttle your function. That means if there are too many requests for Lambda to handle, then there is some, it might so happen that Lambda function might go in a loop, or there may be a issue of timeout. So this throttling normally helps you to understand what will be the behavior, or when your function will get terminate. Okay. So that was regarding the throttling. Next one is the code part. So in code, if you see, I have my index.js. So basically this function is defined in Node.js. Okay. So you can similarly have Python and other languages. Okay. So in the code, I have these files. I can even have the dependencies, that is the node modules and all those things incorporated in this package. Okay. But for simple computing, just to pull the record, I have not used those node modules. But in your case, if you need those modules, then you are good to use it. Okay. So here in the code block, I can define and add my business logic. Okay. So it is something you can use to send a response and the status code. Okay. The next part is the event and the context. Okay. So if you see the handler here, we have the event. Okay, but let's take an example of this function. So here we have event as well as context. So event normally is something which you send in your request body. That means if you want to send a payload that will have some user information. So here I am sending a payload user ID in the request payload. So I can access that user ID using this event object. Okay. Similarly, I can use context to understand how much time this Lambda is taking to process, or real-time information about what are the errors that might occur during the execution, and all those aspects wherein we want to store the log, that we want to use the log. Everything is accessible using this context object. Okay. If you need to know more details about what are the different things that you can use in context, you can check their official documentation, and you will come to know more about it. And is it really required for your function execution? You will come to know about from that. Okay. So these are the two params that you can use. Okay. Then there is a test block. So if you see here, I have a test event. Okay. For a better understanding, let's look at this test event. Okay. So in here, as you have seen that I have this trigger, the API gateway, and there will be some request payload that will be sent in API gateway. Okay. So it can be the user information or the headers. So I can simulate that request body here. Like in the body parameters, I can send the user ID, I can send a resource, I can send a path. So this resource and path, what we had covered in the previous session. So kindly refer to that session video to understand what this resource and path is. But for now, you can understand this as the API endpoint. Okay, the path of the API endpoint. Next, the type of method which will be helpful for making that request. Okay, so we are mentioning what type of method it should make a call to get the response. Okay, so let's try to test this. Okay, so this test actually helps you in selecting the event. Okay, so this event is basically what you define here, the saved event. Okay, so it seems that we have our status code 200. That means the request was successful. At the same time, we have few items here from the DynamoDB, that is leave ID to name, test2, and the status of that leave. Okay. At the same time, we can see the log details like the request ID, the end request ID, and the report, like how much time this function took for the execution. Okay. So this is an overall idea how you can use a test block or the test method. Okay. Next is monitor. So monitor normally helps you in keeping track of CloudWatch and check the logs, how many requests are done, how many invocations are done, for how long the Lambda got executed, and all that information is actually available here, and you can check it. Okay. Yeah. So these are the metrics which helps you to understand what is happening in the background of this Lambda function. The next one is the configuration. So in general configurations, you just set up the memory, how much computation is required. So if on an average your function is not that much big or it doesn't need that much of processing time, you can keep bare minimal memory. Okay. Similarly, what we had seen, the trigger, which AWS service will trigger this Lambda, so that you can add that trigger, that AWS service which will invoke this Lambda function. Another aspect of this configuration is permissions. So let's say I want to execute some query on my DB. So it is important that we give this Lambda that permission to execute that query. Okay. So in our case, we want to execute a Lambda function, a DynamoDB. We want to make a call to DynamoDB such that we want to pull the record. So in such case, we need a role, execution role, which will allow us to execute and get all the records from the DynamoDB. Now, those who are not sure what this role is, so basically this is a part of a service, identity and access management. Okay, it's a IAM service which helps you to create a role and then put this role to this function, okay, or any of the AWS service, so such that you are able to access that service. Okay, so it's like you're granting this Lambda function a permission to execute and pull the records from DynamoDB. Then we have this other resources, the key management service, okay, to store the access and all those things. And there is a resource, the policy statement and other part. Then we have the destination. So in destination, we normally have SNS or any other AWS service which needs to get triggered once we have some result from that Lambda function. Okay, like SNS, if you want to broadcast that whatever information that you get as a result out of the Lambda function, then you can integrate destination as SNS and broadcast that message to the end users. Similarly, we can use environment variables to pass some sensitive information, like if you want to make a connection to the DB, or if you want to integrate a third-party library and we need to make an API call and we need to pass those access tokens or all of the information, then we can pass that information with environment variables. Okay. Then we have tags to give more information about this Lambda, which if you need to use this Lambda in conjunction with any other AWS service. Then we have VPC. Now, this VPC normally helps you to limit or set up a system wherein you have your own corporate center and you want to restrict all the API calls or this Lambda function within that corporate center, and people on the internet should not be able to access your Lambda function. So in such cases, VPC configuration helps you in sending or computing whatever code that you have and the operations that you need to perform in your corporate network. For that purpose, we can use VPC and enable the VPC. Then we have monitoring, as I mentioned, the log metrics and all those things. You can even enable enhanced monitoring to track in more depth. Okay. Similarly, active tracing and all those things. Then we have the extensions, like you can create your own tools which will monitor this Lambda function and integrate as a part of these extensions. Then we have concurrency. So concurrency basically is a method wherein it might so happen that there are too many calls at a time for Lambda to process. Okay, like for example, if you are working with e-commerce website and if there is a sale on a particular day, so there will be many users who want to make a purchase and complete the checkout process. So there will be too much load on the computation layer, and it may so happen that some of the orders may not get processed, or there may be issue of timeout and request may not be able to be processed. So in such cases, this concurrency helps us in provisioning and giving more computation power to this Lambda. So with this configuration, you add a booster to your Lambda function such that it will actually execute and provide more computation power to process those orders in your e-commerce site or in your application. So concurrent execution actually increases with this configuration. Then there is asynchronous invocation. So basically this method helps you if you want to execute multiple functions simultaneously. Okay, so if you don't want to if you are not dependent on any of the method to get executed first, then based on that response you want to map that response to another function. Okay, so if you don't want to have that dependency, and if you want your multiple functions to be executed simultaneously, then this asynchronous invocation normally helps you while working with that. Then there are more aspects like the code signing, database proxies, file system, and state machines. So these are the different other aspects which helps if there is a need in your Lambda function. Okay, but for today's session we won't cover that part. Okay. Then there is aliases. So if you, as I mentioned earlier, if you want to have different users to get executed, different users to access different versions of the Lambda, then this actually helps you in having or able to access those different versions. Okay. Similarly, we will be having different versions here once we publish a newer version of the same Lambda function. Okay. So these are the different components that are there in Lambda. Okay, I hope this gives a basic idea about how different components of this Lambda function works. Okay, let's move on to the languages. Now, as a graduate, and I'm sure you are you will be graduate. You will get graduated from your university. So you may have different preferences, or you might already have some experience with some of the languages. So if you want to work with Lambda and make a career in Lambda, it is important that you need to have some of the basic or some idea in these languages. Okay. So these are the languages that are supported by Lambda. So first one is Node, then there is Python, then there is Ruby, Java, and Go, and C#. So it is important that you have some knowledge in these languages in order to work with Lambda. Okay. So Node, we already saw the JS related framework. Okay. So you can define if you are good with JavaScript, you can go ahead with Node. Similarly, you can go with Python, Ruby, Java, and other options. Okay. Let's see some of the services which you can integrate with Lambda. So Alexa. Alexa, as we know, the voice recognizing platform or the device. So now in Alexa, you may give a chain of command, but for the machine to understand and then get that information from the data center, it is important that we need to have some computation layer in between. So Alexa normally takes your voice commands, converts it into the speech, and then speech need to be checked and map with the data center and then pull the information. So this intermediate compute layer is where we use Lambda. Okay, so this speech to text conversion, so everything that needs to be done is done using Lambda. Then we have API gateway, as we have seen in here, that for a trigger point and sending that request payload to Lambda, we make use of API gateway. Similarly, we have DynamoDB. So we use DynamoDB for pulling the records from the table. So we can use this in Lambda. Similarly, we can use S3 events. Okay, if S3 is basically a storage service, okay, object storage service, where if you can store your static data or the larger data like the analytics data, and then you can set up events with Lambda. So once you upload any of the document in S3, you can trigger Lambda and process that document. Okay, or if you want to store meta information of that document, then you can use Lambda to get that event stream, that is the object information, and further store it in other storage. Okay, then we have event bridge and CloudWatch event. So this you can integrate with EC2. So if you want to keep track of what are the different things that are happening with your EC2, that is, EC2 is basically a hosting platform or where you host your website. So if something is wrong with your platform, or there is too much load on your EC2, then you can set up Lambda to provision more EC2 and handle the traffic. Similarly, we can have CloudWatch logs. So we can set up check with the metrics, which will send the data of what are the different issues or errors that occur from the CloudWatch to Lambda. Then we have CloudFront. So basically, if we want to execute our Lambda function, so there is a method with Lambda Edge, which will serve the computation part throughout the world with lowest latency. Okay, so it basically works like a CloudFront, and it serves the traffic at much faster pace. Then we have Kinesis for real-time data processing or the analytics. So we can integrate Lambda with this. Then we have SES, SNS, which works well with Lambda. Okay, so there are more services, AWS services, which you can use along with Lambda for different reasons and as per your platform needs. Okay, so these are some of the features or advantages that comes into picture when we work with Lambda. So it's easy to use because you don't have to actually set up a server, or there is no hardware setup that you need to worry about. It is just the code or the language that you need to know to work with Lambda, and your code will execute accordingly. Then you can easily monitor, as we had seen, the function log, which helps us to get more information about the execution and other aspects. Then it automatically scales up, so you don't have to actually worry about keeping a backup of hardware backup, or having more computation during the time of too much traffic or too much load on your platform. Then it automatically scales up, so you don't have to actually worry about scaling it manually. Okay, then faster speed of execution. As it scales, you have the flexibility of the speed, so your overall computation is much faster. Then it's highly available. That means a single hardware failure doesn't affect your function, because you have that multiple servers backing up that Lambda function, so it automatically switches from one server to another server. So it is highly available. And as this is a serverless service, you have the option of pay as you go model. So the amount of computation that you do, only you need to pay for that and nothing more or less. Okay, so this is a good aspect of Lambda. Now these are the some of the recent updates that actually I would say the upgrades that happened to the Lambda. So Lambda now supports Graviton 2, the functions using ARM64 architecture. So this is more to do with the platforms or the infrastructure related support. Then it now supports Python 3.9. So it may so happen that while you work with the languages, you may work with the latest versions of the of those languages, and you may not see that versions available with Lambda. So you don't have to actually worry about that. It is constantly updated, and there are newer versions that are supported by Lambda. So with these updates, it supports the newer versions, and you don't have to actually worry about updating it by yourself. Okay, then it also supports the new Rabbit MQ. So it is actually a service where you send the messages and then one by one you process those messages. Okay, so it's like a queue wherein you push the you send the messages and then you pull those messages. So you pull those messages and then process the further part of it. Then there are more updates with extensions. So what I have explained before, you can develop new extensions if it is required in your Lambda function. So they now come up and provision and allow users to use the extensions developed by their partners. Okay, so you can have now more extensions which you can use along with Lambda. So these are some of the customers that are actively using Lambda. Okay, so if you see, there are broad spectrum of companies that are using Lambda for different purposes. So first one, they are using it for educational apps or the courses. Then there is analytics. They process the data with Lambda. Then the Coca-Cola, they have their touchless fountain experience with Lambda. Then business to business transaction process used by Steady. So similarly, there are different customers which use Lambda for different aspects. So it is up to you how your platform actually needs this Lambda computation. Okay, so these are only few customers I have listed here. There are many more who you actively use Lambda for their business logic. Okay, yeah, so I hope this gives you an enough information and insight on how you can work with Lambda and take a career path in Lambda. Thank you all for joining this session, and I hope this helps you in some way to make your career in this AWS serverless.